Welcome to the DIY Honda Garage channel. This presentation addresses DTC P2A00, which is associated with an issue in the air-fuel AF sensor, specifically Sensor 1 in the Honda Civic models from 2022 onwards. When the output voltage of the AF sensor deviates significantly from expected oxygen concentration levels during periods of deceleration, the Powertrain Control Module, PCM, recognizes this abnormal behavior and triggers the code P2A00. The AF sensor plays a crucial role in regulating the air-fuel mixture by monitoring the oxygen level in the exhaust gases. Positioned in the exhaust system, it detects the air-to-fuel ratio, providing essential data to the PCM for optimal engine performance. Understanding how to troubleshoot this error code is vital for maintaining vehicle efficiency and emissions compliance. This guide will encompass error descriptions, possible causes, symptoms, and step-by-step troubleshooting procedures to rectify the fault effectively. The AF sensor, Sensor 1, is a critical component in the vehicle's emissions control system and is responsible for ensuring the correct air-fuel mixture is achieved during combustion. Positioned in the exhaust system, it actively monitors the concentration of oxygen in the exhaust gases. When the sensor detects a significant deviation from the expected output voltage during specific driving conditions, the PCM triggers DTC P2A00. This code indicates a range or performance issue with the AF sensor, suggesting that essential data being sent to the PCM may be inaccurate. Addressing this error is crucial, as an inefficient air-fuel mixture can lead to poor engine performance, increased fuel consumption, and heightened emissions. Proper function of the AF sensor ensures that the engine operates effectively across varying conditions, making its performance pivotal for overall vehicle efficiency. Several factors can contribute to the occurrence of DTC P2A00. The most common cause is a faulty AF sensor itself, where the sensor may not accurately read the oxygen levels, resulting in incorrect voltage output to the PCM. Additionally, wiring issues, such as frayed wires or poor connections, may disrupt the signal from the AF sensor, leading the PCM to interpret this as a malfunction. Another potential reason could be errors in PCM processing, where the module does not accurately interpret the data received from the sensor. Environmental factors, such as exhaust leaks or intake manifold leaks, could also affect the sensor's performance. Thoroughly diagnosing these potential causes is essential for identifying the root problem and ensuring proper repairs are made to restore functionality. When DTC P2A00 is triggered, drivers may experience several noticeable symptoms. The most immediate sign is the illumination of the check engine light on the dashboard, prompting the need for diagnostic attention. Additionally, vehicle owners might notice a drop in fuel efficiency as the engine struggles to maintain the optimal air-fuel ratio due to the sensor malfunction. Furthermore, engine performance issues may arise, including rough idling, hesitation during acceleration, or even stalling in severe cases. These symptoms not only indicate a potential fault within the AF sensor system, but also highlight the necessity for timely repairs. Ignoring these signs could lead to further complications, including increased emissions and potential long-term damage to the vehicle's engine components. The first step in troubleshooting DTC P2A00 is to start the engine and allow it to reach operational conditions. Set the engine speed to 3,000 RPM without load. This means the continuously variable transmission, CVT, should be in park or neutral, and if it's a manual transmission, it should be in neutral as well. This step is essential to ensure that the vehicle reaches a proper temperature and allows the components involved, including the AF sensor, to function correctly. Hold this engine speed until the radiator fan activates, indicating that the engine is reaching an appropriate operating temperature. This initial phase is vital for setting the stage for the following diagnostic steps, as the engine needs to be in the right condition for accurate sensor readings and diagnosis. Once this is confirmed, you can then proceed to the next phase of diagnostics to pinpoint the issue further. Following the initial engine warm-up, the next crucial step involves a test drive of the vehicle under specific operating conditions. It is essential to monitor the engine coolant temperature, ECT Sensor 1 reading, ensuring that it exceeds 158 degrees Fahrenheit, 70 degrees Celsius. This temperature indicates that the engine is working within a valid range for emissions testing. During the drive, the vehicle should be operated in drive gear for CVT or in 4th or 5th gear for manual transmission, achieving a speed between 25 to 55 miles per hour, 40 to 90 kilometers per hour, for a duration of at least 5 minutes. After maintaining this steady speed, accelerate briefly between 55 to 75 miles per hour, 90 to 120 kilometers per hour, and then decelerate with the throttle fully closed for a minimum of 5 seconds. This step simulates real-world conditions, allowing the PCM to assess the sensor's performance accurately. After the test drive, the next step is to monitor the HDS, Honda Diagnostics System, for the OBD, onboard diagnostic status, and check if DTC P2A00 remains active. Once DTC P2A00 has been reviewed post-test drive, the next troubleshooting step emphasizes inspecting the AF sensor's wiring and connections. First, visually examine the wiring harness leading to the AF sensor for any visible damages, such as frayed wires, corrosion, or disconnections. It's crucial to ensure that the wiring is intact, as any faults here can lead to incorrect signal transmission to the PCM. Additionally, check that all connections are secure, as loose or corroded connectors may hinder the sensor's correct functionality. If any issues are found, repair or replace the damaged components as necessary. This step is vital, as the accuracy of signals sent to the control module directly influences engine performance and emissions. Following these checks, retest the system to see if DTC P2A00 persists, which may provide insight into whether the sensor itself requires replacement. If the previous troubleshooting steps indicate that the A-factor sensor is faulty, the next step involves replacing the A-factor sensor with a new unit. It is essential to use a genuine or high-quality replacement sensor suitable for the Honda Civic 2022 Plus. Once the new sensor is installed, clear any diagnostic trouble codes stored in the PCM. This procedure ensures that any leftover codes from the previous sensor do not interfere with the new sensor's operation. After resetting, it's crucial to perform another test drive while monitoring the vehicle's performance and the HDS readings to verify that DTC P2A00 does not reappear. Successfully replacing the sensor should restore normal operation, as the new component will provide accurate readings for the PCM. This step confirms the resolution of the issue while ensuring the vehicle's efficiency and compliance with emission standards. Final verification is crucial after addressing DTC P2A00 to ensure that the repair was successful and the vehicle is performing optimally. Start by confirming that no diagnostic trouble codes remain stored in the PCM using the HDS. If the codes have been cleared, monitor the vehicle's overall engine performance, paying attention to acceleration, idling smoothness, and any unusual behavior. It's also important to note any improvements in fuel efficiency, as a correct air-fuel mixture should yield better fuel economy. Conduct a test drive under various conditions to confirm that the vehicle responds correctly without triggering any warning lights or error codes. This step is critical for restoring driver confidence in the vehicle's performance and ensuring that the repairs have resolved the underlying issues effectively. Preventive maintenance is essential for keeping the AF sensor functioning correctly and avoiding the emergence of DTC P2A00 in the future. Regularly checking the AF sensor during scheduled maintenance can help detect issues early, allowing for timely replacements or repairs. Additionally, routine inspection of the wiring connected to the sensor will help identify any wear or damage that could disrupt its operation. Maintaining engine cleanliness is also crucial. Dirt and debris can affect the sensor's performance, so ensuring a clean environment around the exhaust and intake areas plays a significant role in sensor efficiency. Furthermore, using high-quality fuel and oil can minimize deposits that might negatively impact the sensor's functionality. Engaging in these proactive measures can significantly prolong the lifespan of the AF sensor and support the overall health of the vehicle. In conclusion, DTC P2A00 is a significant diagnostic code associated with an air-fuel sensor circuit range or performance issue in the Honda Civic 2022 Plus. Understanding the critical role of the AF sensor in managing the engine's air-fuel mixture is key to maintaining optimal vehicle performance and emission standards. Drivers should remain alert to symptoms such as the check engine light, poor fuel efficiency, and potential performance issues, as these signs may indicate a malfunction in the AF sensor system. Conducting thorough troubleshooting steps, from monitoring engine conditions to inspecting and possibly replacing the AF sensor, is essential for resolving this issue effectively. Lastly, engaging in regular preventive maintenance, including routine checks on the sensor and its connections, can help ensure long-term reliability and performance, reducing the risk of future DTC occurrences. Please like and subscribe to the channel. See you next time.